Mars. The very name conjures images of a rusty alien landscape, a world that has captivated human imagination for centuries. We see it as a potential second home, a place to unlock the secrets of life beyond Earth. Yet this seemingly serene world harbors a phenomenon so vast, so powerful, it can engulf the entire planet. This is something that causes even the brilliant minds at NASA to hold their breath. It's something far more insidious, woven into the very fabric of the Martian environment. It is the dust. Fine as talcum powder, this dust can be whipped up by winds into storms of unimaginable scale. These are planet-encircling behemoths, capable of blotting out the sun for weeks, even months. Imagine a world where the sky turns a murky, oppressive orange, and a relentless fine powder seeps into everything. This is the reality that our robotic explorers have faced, and it's a stark warning for future human missions. Understanding them, predicting them, and ultimately surviving them is paramount if humanity is to ever set foot on, and perhaps one day inhabit this captivating yet perilous neighbor. The red dust holds secrets, but it also holds a profound threat. Mars demands respect, and its dust storms are perhaps its most potent way of reminding us of the challenges that lie ahead. Mars is a truly remarkable world. It's often called the Red Planet, and for good reason. Its surface is covered in iron oxide rust, essentially, giving it that distinctive reddish hue. But it's so much more than just a rusty rock. It boasts the largest volcano in the solar system, Olympus Mons, 3 times the height of Mount Everest. It also has Valles Marineris, a system of canyons that dwarfs our own Grand Canyon. Scientists believe that billions of years ago, Mars may have had a thicker atmosphere and liquid water on its surface. There could have been rivers, lakes, perhaps even oceans. And where there's water, there's the tantalizing possibility of life. This is why we send rovers, orbiters, and landers to search for clues of past or even present microbial life. Each new discovery, each image sent back, paints a more detailed picture of this enigmatic world. By studying Mars, we learn more about Earth and our place in the universe, yet, for all its stark beauty and scientific promise, Mars is not a welcoming place. Martian dust storms are unlike anything we experience on Earth. While we have dust storms in our deserts, they are typically localized and relatively short-lived. On Mars, these events can escalate dramatically. They begin in a small area, perhaps a few hundred kilometers across, but under the right conditions they can grow, merging with other storms until they become regional or even global phenomena. A global dust storm on Mars means the entire planet is shrouded in a thick haze of dust. What makes them so terrifying is their sheer scale and persistence. Imagine the sun, our primary source of power for solar-powered rovers, being blotted out for weeks or even months. The amount of dust lifted into the atmosphere is staggering. This fine particulate matter can reach altitudes of over 60 kilometers. The winds that drive these storms can be fierce, though the thin atmosphere means they don't exert the same force as Earth winds. However, they are more than capable of lofting vast quantities of this fine dust. Our robotic explorers, the rovers and landers sent to Mars, are our eyes and ears on this distant world. They are marvels of engineering, designed to withstand harsh conditions. However, Martian dust storms pose a profound threat to their operation and survival. The most immediate impact is on solar-powered rovers. When a massive dust storm kicks up, it significantly reduces the amount of sunlight reaching the surface. This is critical because rovers like Spirit, Opportunity, and even the more recent Perseverance need sunlight to charge their batteries and continue their scientific work. The story of the Opportunity rover is a poignant example. Opportunity landed on Mars in 2004, with a planned mission duration of just 90 Martian days. Incredibly, it kept exploring for nearly 15 Earth years. However, in 2018, a planet-encircling dust storm engulfed Mars. The sky darkened to such an extent that Opportunity could no longer generate enough power to keep its systems running. NASA engineers hoped that once the storm subsided and sunlight returned, the rover would wake up. Sadly, despite months of trying to re-establish contact, Opportunity remained silent, its mission finally ended by the relentless Martian dust. While dust storms are a major problem for robots, they pose an even more complex and dangerous threat to future human missions. Astronauts on Mars will rely on a multitude of systems for survival habitats, life support, power generation, and spacesuits. The fine Martian dust, if it infiltrates these systems, could have catastrophic consequences. Imagine trying to maintain airtight seals on habitats and airlocks when a constant barrage of microscopic particles is trying to work its way in. Any breach could lead to a loss of breathable air or contamination of the living environment. Spacesuits are particularly vulnerable. This dust is not just fine, it can also be abrasive. It could degrade the materials of the suit, compromise seals on helmets and gloves, and clog filters in the life support backpack. The Apollo missions to the moon provided a stark lesson. Lunar dust, though different from Martian dust, caused significant problems for the astronauts. Martian dust could be even more problematic due to its chemical composition and fineness. The red dust is a silent, pervasive enemy. The sheer formidability of Martian dust storms stems from a unique combination of factors specific to the red planet. Firstly, the dust itself is incredibly fine, with particles typically only a few micrometers in diameter. This microscopic size means that once lifted it can remain suspended in Mars's thin atmosphere for very long periods. The lower gravity on Mars, about 38% of Earth's, also helps these particles stay aloft longer. Secondly, the Martian atmosphere, though thin, is still capable of generating significant winds. These winds are driven by solar heating. As sunlight warms the Martian surface, temperature differences arise between different regions. These temperature gradients create pressure differences which in turn drive winds. During certain seasons, particularly when Mars is closest to the Sun, these temperature contrasts are amplified, leading to stronger winds capable of lifting vast quantities of the fine surface dust. Another fascinating and dangerous aspect is the potential for electrostatic effects. As these tiny dust particles are whipped around by the winds, they rub against each other and against the Martian surface. This friction can generate significant amounts of static electricity, a phenomenon known as triboelectric charging. NASA is acutely aware of the threat posed by Martian dust storms and has developed sophisticated strategies to monitor and mitigate their impact. Orbiters like the Mars Reconnaissance Orbiter, MRO, and MAVEN constantly observe the Martian atmosphere. These spacecraft track dust storms, measure atmospheric temperature and dust opacity, and provide early warnings to missions on the surface. This vigilance offers precious time to prepare. When a significant dust storm is detected, mission controllers at NASA's Jet Propulsion Laboratory, JPL, spring into action. For solar-powered rovers like Opportunity, this meant managing power consumption. Non-essential activities would be curtailed, and the rover might be put into a low-power hibernation mode. Engineers closely monitor the tau value, a measure of atmospheric opacity, to gauge how much sunlight is being blocked by the dust. For nuclear-powered rovers like Curiosity and Perseverance, the immediate threat to power is less, but dust accumulation remains a concern. These rovers carry meteorological sensors that provide data on wind speed, direction, temperature, and pressure. This information helps refine global atmospheric models. Looking towards future human missions to Mars, the challenge of Martian dust storms requires even more advanced engineering solutions. Habitats will need to be fortresses against the fine, pervasive dust. This means sophisticated air filtration systems, far exceeding what we use on Earth or even on the International Space Station. Airlocks will be critical transition zones incorporating multi-stage cleaning processes to prevent dust from being tracked inside. Astronauts might even use suit ports, where a spacesuit is docked externally to the habitat, allowing an astronaut to enter the suit without bringing it or the attached dust inside. For spacesuits themselves, engineers are exploring new materials that are more resistant to abrasion and less prone to dust adhesion. Developing effective methods for cleaning suits after each EVA will be paramount. This could involve specialized brushes, vacuum systems, or even electrostatic dust mitigation techniques that use electrical fields to repel or collect dust particles. The lessons learned from the Apollo lunar missions, where abrasive lunar dust caused significant issues, are being carefully studied and applied to the Martian context. Power systems for human outposts will need to be incredibly reliable and resilient. While nuclear fission reactors are considered a prime candidate for providing consistent baseload power, solar arrays will likely still be used for supplementary power or in specific locations. For these, technologies to mitigate dust accumulation are being researched. The Martian dust storms, in all their terrifying grandeur, represent more than just an environmental hazard. They are a profound symbol of the challenges in humanity's quest to become a multiplanetary species. Mars, with its ancient allure and potential for discovery, beckons us. Yet it also reminds us that venturing beyond Earth is an undertaking of immense complexity and risk. Overcoming these storms is a critical step on our journey to establishing a sustained human presence on the Red Planet. This endeavor pushes the boundaries of science, engineering, and human endurance. The solutions we develop for Martian dust will have applications here on Earth. Think of improved air quality control in polluted cities. The dream of colonizing Mars is a powerful one. It speaks to a deep-seated human desire to explore and ensure the long-term survival of our species. The red dust may swirl and rage, but the human spirit of exploration will continue to reach for Mars.